Yesterday I was explaining you the important postulates in the collusion theory. Once again I am repeating that postulates. I think 2 or 3 postulates are left in that. So once again I am repeating that postulates. Yesterday I was explaining you the important postulates in the collusion theory. Once again I am repeating that postulates. I think 2 or 3 postulates are left in that. So once again I am repeating that postulates. Yes, postulates in the collusion theory. First one, collusions are responsible for the chemical reaction. Colliding molecules should collide in proper orientation. This is the first postulate. And the second one is, colliding molecules should possess certain minimum amount of energy. Then the collusion between them gives the product. That energy is called as the threshold energy. That is called as threshold energy. This is the second postulate. And the third one, energy of the general molecule is very less when compared with the threshold energy. This is the threshold energy level. This is the energy of general molecule. Energy of the general molecule is very less when compared with the threshold energy at STP. Now fourth is, the difference between the threshold energy and energy of this general molecule is called as activation energy. Activation energy. The molecules which are having this threshold energy are called as activated molecules, and collusion between them gives the product. Now next postulate, activated molecules are formed by the collusion between the general molecules. See that? Activated molecules are formed by the collusion between general molecules. This is the activated molecule. Collusion between the activated molecules gives rise to what? Product. So this is the another postulate. Now next one, sixth postulate. Activated collusions are very less in number when compared with the general collusions. What is the meaning of that? A plus A. These collusions are more in number when compared this type of the collusions. Okay. This is about the sixth postulate. Next, seventh one, number of collusion in a unit length area in a second time. In a second time, how many collusions are takes place? That is called as the collusion frequency. That is the next postulate. And the last postulate, specific rate of the reaction. What is the meaning of that? Rate of the reaction, velocity of the reaction is directly proportional to the temperature. If the temperature is increases, speed of the reaction is increases. That is given with the equation, that is the Arrhenius equation, K is equal to AE power minus CA by RT. This is the equation is called as the Arrhenius equation. So these are the important postulates in the collusion theory, and it is the important question in the 19th one. 19 में 3 क्वेश्चंस बोले थे, उसके अंदर एक collusion theory important है. एनुअल, लास्ट एनुअल में अपने को एग्जाम में पूछे थे ये क्वेश्चन, फिर भी आ सकता है क्वेश्चन. This is about the collusion theory. Now next, continuation of this. After the collusion theory in the 19, मैं लास्ट क्लास में बोला था 19 में 2 बिट्स बनाता बोल के, एक collusion theory का और बी बिट जो है सेकेंड वाला galvanic cell. So I am explaining you about the galvanic cell. What is the galvanic cell? Yes. What is the galvanic cell? A device that converts the chemical energy into the electrical energy by using spontaneous redox reaction. In the galvanic cell, what is taking place? With the help of the redox reactions, chemical energy, chemical energy is converted to what? Electrical energy. Electrical energy. Conversion chemical energy is converted into the electrical energy. A device that converts the chemical energy into the electrical energy is called as the galvanic cell. This is the definition of the galvanic cell. So then after the definition, what is the construction, how it is made, I am going to explain you. A galvanic cell consists two half cells. One is this one, okay, it is called as a LHS, left hand side half cell, in which zinc sulfate solution. Galvanic cell consists two half cells. One is the left hand side half cell and second one is the right hand side, this one. So in this RHS I am writing, copper sulfate solution is taken and one copper rod is dipped in this zinc sulfate solution and one zinc rod is placed in this. It consists, that means galvanic cell consists two half cells. Left hand side is filled with the zinc sulfate solution and zinc rod is present dipped in it. Right hand side half cell contains CuSO4 solution and copper rod is dipped in it. Now then after this, these two are internally connected with the U-shaped glass tube, that is called as the salt bridge, and these two are externally connected to the this one external circuit से मिला देते हैं इसको. So this is about the construction of the galvanic cell. Once again I am repeating this. What is a galvanic cell? First you have to write the definition. Galvanic cell is a device that converts the chemical energy into the electrical energy by using the spontaneous redox reactions. Oxidation reduction reaction takes place in this. As a result of that, chemical energy is converted to the electrical energy. This galvanic cell consists two half cells. Left hand side contains ZnSO4 solution and one zinc rod is present in that. Right hand side, this is the half cell contains copper sulfate solution and one copper rod is kept in it. Then internally these two are connected with the U-shaped glass tube which is filled with the KNO3 and agar-agar. So this is the U-shaped glass tube called as the salt bridge, and these two are externally connected to the battery. This is about the construction of the galvanic cell. Now then what are the reactions takes place in this galvanic cell? I am writing it here. In the left hand side, this is the reaction takes place. At here Zn is converted to the Zn plus 2 and 2 electron. Losing of the electron is called as the oxidation. In the left hand side, oxidation reaction takes place, and in the right hand side, Cu plus 2 takes the electrons and converted to the Cu. This is the reaction. What are the overall reactions in this galvanic cell? This is the overall reaction. Zn plus Cu plus 2 gives rise to Zn plus 2 plus Cu. This is the overall reaction. It is represented with a simple method that is called as the cell notation. Simplest method to represent the cell reaction is called as the cell notation. In the cell notation we are writing this left hand side reaction like this. Zn is converted to the Zn plus 2 and which is separated with the salt bridge. Two parallel lines you have to write. Now then right hand side Cu plus 2 is converted to the Cu. This is called as the galvanic cell notation. This much is enough in this galvanic cell. So this is about the another important explanation, another important question in the 19th one. In the 19th question I was explained you collision theory postulates, and the second one is the galvanic cell. Now then another important 19th question, 19 में जो आने वाला और एक LAQ जो important है वो Colrosh law के applications. Colrosh law, state and explain the Colrosh law. Colrosh law. कॉलरॉश लॉ को स्टेट करो और एक्सप्लेन करो बोल के दे रहा, इसके एप्लीकेशंस के बारे में दे रहा. What is the Call-Roche law and write its applications? This is the another question. So in this Call-Roche law, first you have to give the statement. What is the Call-Roche law? So Call-Roche law is nothing but the limiting molar conductance. Limiting molar conductance at infinite dilute solution. Limiting molar conductance, I am writing like this, is sum of the conductance. See here I am writing the AB, this is an electrolyte. Molar conductance of an electrolyte is equal to the sum of the conductance of the, equal to the value, equal to the value, is equal to the sum of the conductance of the cations and anions which are present in the solution. You have to write like this. Okay, this is the statement. Once again I am repeating this statement. Limiting molar conductance of electrolytic solution is equal to the sum of the conductance of the cations and anions present in that solution is called as the Call-Roche law. This is the definition. For example, I am writing this. Molar conductance of the NaCl is how much? Molar conductance of the NaCl is nothing but the you see that molar conductance of how many ions are there? Cation, that is Na plus, and molar conductance of the anion present in this solution, Cl minus. This is about this statement. Now then explanation of the Call-Roche law. How we have to explain this Call-Roche law? Once again I am repeating this. Limiting molar conductance of infinite dilute solution is equal to the sum of the conductance or contributions of the cations and anions present in that solution is called as the Call-Roche law. Now then I have written that equation, you see that. Now then I am explaining you explanation for the Call-Roche law. If the conductance of Na plus ions, if the molar conductance of Na plus ion is written with this, that is Na plus, very simple, you have to write like this only. Now then if the molar conductance of Cl minus ion can be written like this, then the total conductance of the NaCl is equal to the conductance of what? Na plus and conductance of Cl minus. So this is the explanation of the Call-Roche law. Now then after this, what are the uses or applications of the Call-Roche law? I am explaining you applications of the Call-Roche law. Applications. In the application, first one is molar conductance of an infinite dilute solution. Molar conductance of a weak electrolytic solutions like the acetic acid. Molar conductance of the acetic acid. This is a weak electrolyte. Molar conductance of the weak electrolytes can be calculated with the help of the Call-Roche law, by means of the Call-Roche law. How we can calculate it? Just you see that I am writing this formula. Lambda naught, that is this conductance of the acetic acid is equal to the, just you check it out, this is the formula I am writing. First you have to take the salt of this CH3COO and now then plus conductance of HCl I am taking. You remove this, the conductance of NaCl from this, you will get the conductance of what? Minus I am writing NaCl. By removing NaCl, what we are getting? CH3COOH only. So this is the way to calculate the molar conductance of the weak electrolyte of the acetic acid. This is the first one, first application. Now the second application is degree of dissociation of weak electrolytes can be calculated. Extent of dissociation is called as the degree of dissociation. Extent means what is the meaning of the extent of the dissociation? How much that is dissociated in the water? That is called as the extent of dissociation. Extent of the dissociation, that is dissociation constant, can be calculated with the formula dissociation at the known concentration, ऐसा डाल लेना, dissociation at the known concentration dissociation at the infinite dilute solution. ओके खूब पानी मिला दिया, कितना डिसोसिएट हो रहा है, उसका कंडक्टेंस देख लो और नॉन कंसंट्रेशन के पास इसकी मोलार कंडक्टेंस देख लो, इन दोनों के रेशियो से आपको डिसोसिएशन कांस्टेंट आता। सो दिस इज अबाउट द सेकंड एप्लीकेशन। द थर्ड एप्लीकेशन इज solubility of the sparingly soluble salt can be calculated, can be known. Solubility of the sparingly soluble salt. Okay, solubility of the sparingly soluble salt S. This is the solubility. Okay, this can be calculated with the formula, that is this one. Okay, conductance at the infinite dilute solution. So by means of this formula we can calculate the solubility of the sparingly soluble salt like BaSO4 can be calculated. These are the some applications which are there in the Kohlrausch law. Once again I am repeating the application. First application is conductance of the weak electrolytes like acetic acid can be calculated. Second one, degree of dissociation can be calculated. Now third one, solubility of the sparingly soluble salt can be calculated with the help of the Kohlrausch law. So these are the some important questions which are going to come in the 19th वाले क्वेश्चन में। ये जो क्वेश्चंस है मैं जो पढ़ाया, कोल्यूशन थ्योरी, गैल्वेनिक सेल और कोलरॉश लॉ, और उसके साथ में और एक ऑर्डर एंड मॉलिक्यूलरिटी बोलने वाला क्वेश्चन है। ऑर्डर एंड मॉलिक्यूलरिटी, डिफाइन व्हाट इज ऑर्डर, व्हाट इज द मॉलिक्यूलरिटी, राइट द एग्जांपल्स फॉर द order, first order, zero order, like that. Some questions are some examples are there, you have to write. So I am explaining you about the order and molecularity. That is also important. 19th question, order and molecularity. What is the order of the reaction and what is the molecularity? First I am explaining you order of the reaction. Order is nothing but the, I am writing this equation, A plus B gives rise to what? Product. So first you have to write this equation, that is like this: R proportional to rate of the reaction is proportional to concentration of A and concentration of B, like this. This is called as the rate law equation. ऐसा लिखने को rate law equation बोलते हैं. That gives the relationship between the rate of the reaction to the concentration of the reactants. The mathematical relationship which gives the rate of the reaction and concentration of the reactants is called as the rate law equation. Now then by doing the experiment we are finding the powers of the concentration. For example A है, इसकी concentration को double करके देखा, experiment करके देखा, अगर velocity of the reaction भी double हो गया तो क्या लेना, इसका power 1 लेना है, experimentally calculated. If the concentration of A is doubled, if the rate of the reaction is also double, now then power of the concentration of A can be written as 1. If you are doubling the concentration of B, once again if the rate of the reaction is doubled, now then power of the concentration can be written as power 1. Now then what is the order of the reaction? Order is nothing but the sum of the powers of the concentration. In which equation? Rate of the equation. First we are writing the rate law equation, rate law expression, then we are finding the powers of the concentration, now then we are adding the powers of that concentration. Sum of the powers of the concentration in the rate law equation is called as the order of the reaction. This is the definition. Order values are experimental values. Without experiment we cannot predict these order values. All these order values are experimental values, and order values sometime may be negative and sometime equal to 0, and that may be positive or negative. Order values may be positive, negative or equal to 0. Now then this is about the definition of the order of the reaction. Now then I am giving you some examples for the zero order, first order and second order equations. Okay, so these are the some examples. First one I am writing this one, dissociation of HI is the example. HI or N2 plus 3 H2, 2HI gives rise to H2 plus I2, dissociation of HI. Now N2 plus 3 H2 gives rise to 2NH3. These are the example for the zero order reaction. H2 plus Cl2 gives rise to 2HCl. These are the examples for the zero order reaction whose concentration, whose That means rate of the reaction does not depends upon the concentration. By doubling the concentration of this also, rate of the reaction is does not changes. That is the reaction is called as the order zero order reaction. Now then I am writing the equation for the first order reactions. First order H2O2, dissociation of H2O2 gives the H2O plus half O2. This is the example for which order? First order reaction. This is about the order of the reaction. Now then what is the molecularity of the reaction? Molecularity of the reaction. Molecularity for the molecularity of the reaction. Molecularity. What is the molecularity of the reaction? See that for the molecularity we have to see the mechanism. For example, A is a reactant that is converted to the product D. During the formation of A to D, some steps are there, intermediate steps are there. That is, A is converted to B. Now then B is converted to C and C is converted to what? D. So these are the some steps are there for the formation of the A into the D. For the conversion of A to B, suppose I am writing this takes about the 5 minutes of time. Okay, for example, I am telling you A conversion of the A to B takes 5 minutes time, and conversion of the B to C takes 10 minutes time, and conversion of C to D takes 3 minutes time. Now see that which is the slowest step of the mechanism in this. Second one is the slowest step of the mechanism. Mechanism के अंदर का slowest step लेना. ये slowest step के अंदर कितने atoms और कितने molecules और कितने ions participate हो रहे हैं? How many atoms or molecules are participated in the slowest step of the mechanism is called as the molecularity of the reaction. Once again I am repeating, for the molecularity we have to see the mechanism. For example, I am writing this one, A is converted to D. For the formation of a reactant A, for the formation of D from the A, following steps are there: A to B, B to C, C to D. In this, conversion of A to B takes 5 minutes time, and B to C takes 10 minutes time, and conversion of C to D takes 3 minute time. So which is the slowest step among these? This is the slowest step. We are seeing how many steps are there during the formation of the product, that is called as the mechanism of the reaction. In the mechanism, we are taking the slowest step. In that slowest step, how many atoms or molecules are participated, I am writing. That is called as the molecularity of the reaction. In the slowest step of the reaction, if only one molecule is participated, that reaction is called as unimolecular reaction. In the slowest step of the mechanism, if two molecules are participated, if two atoms are participated, that reaction is called as the bimolecular reaction. If three molecules are participated, that is called as the trimolecular reaction. Example for the unimolecular, you have to see that molecularity values are positive integral values, and these are the theoretical values only. So example for the unimolecular reaction. Unimolecular reaction को example है dissociation of N2O5, that gives the N2O4 plus half O2. This is the example for the unimolecular reaction. And example for the bimolecular reaction, you have to take like this: H2 plus I2 gives rise to reversible 1,2HI. This is the example for the what? Bimolecular. This is example for what? Unimolecular reaction. And this is the example for the trimolecular. 2NO plus O2 gives rise to 2NO2. This is example for the trimolecular reaction. So this is about the order and molecularity. What is the order of the reaction? Order is nothing but the sum of the powers of the concentration of reactants in rate law equation is called as the order of the reaction. Order values are experimental values, and order values sometimes may be positive, negative or equal to 0. And I have given some examples for first order and zero order. Next, molecularity of the reaction. What is the molecularity? In the slowest step of the mechanism, how many molecules are participated? That is called as the molecularity of the reaction. Number of atoms or ions or molecules are participated in the slowest step of the mechanism is called as molecularity of the reaction. This is example for the unimolecular and it is example for bimolecular, trimolecular. एक एक एग्जाम्पल लिख लिया आप काफी हो जाता. So this is about the order and molecularity of the reaction. इससे ये इंपॉर्टेंट क्वेश्चंस 19 के जो भी थे वो हो गए. 19 के अंदर में क्या क्या पढ़ाया? कोल्यूशन थ्योरी के पोस्टुलेट्स पढ़ाया, फिर उसके बाद गैल्वेनिक सेल पढ़ाया, उसके बाद नेक्स्ट वन कोलरॉशल एंड एप्लीकेशंस पढ़ाया, फिर देन ऑर्डर एंड मॉलिक्युलरिटी विद एग्जांपल्स पढ़ाया मैं. जीरो एंड फर्स्ट ऑर्डर, यूनी बाई मॉलिक्युलर, ट्राइमॉलिक्युलर रिएक्शंस एक एक लिखा मैं. इतना लिखना है बस काफी हो जाता. Now next about the after this I am explaining you about the question number 21. Question number 21. In this question number 21 all our name reactions are there. ये एक ऐसा भी आने वाला क्वेश्चन है, पूरे नेम रिएक्शंस मिले हुए रहते. नेम रिएक्शंस में तीन चार नेम रिएक्शंस को पूछ लेता है. तो in this name reaction first one is the Kolb's reaction. Kolb's reaction. What is Kolb's reaction? Kolb's reaction किसको बोलते हैं? ऑर्गेनिक केमिस्ट्री, ये फिनॉल के अंदर है, ये अल्कोहल्स एंड फिनॉल्स में. Kolb's reaction is nothing but the I am taking the phenol. This is the phenol. बेंजीन पे OH है तो इसको बोलते हैं फिनॉल बोलते हैं. When phenol is heated with or treated with, अब मैं फिनॉल को क्या करा? सोडियम हाइड्रोक्साइड से मिला दिया. When it is treated with sodium hydroxide, what is formed it here? Just you see that you will get the sodium phenoxide. ONA form होता, sodium phenoxide. HOH यहाँ से हटा दो, Na को इधर लगा दो, sodium phenoxide हो गया. When phenol is treated with sodium hydroxide, sodium phenoxide is formed. It is followed by reaction with carbon dioxide in the acidic media. Acidic media में CO2 से react करे इसको, फिर क्या फॉर्म होने वाला है? Just you see that on this फिनॉल फिर से ONA चले जाके H की जगह यहाँ पे Na की जगह H आ जाता राइट साइड में. ये दो COO एज इट इज लिख लो आप, हाइड्रोजन को साथ में मिला दो. तो दिस इज द प्रोडक्ट फॉर्म ड्यूरिंग द Kolb's reaction. This is the reaction is called as Kolb's reaction and the product is, what is the name of the product? This is called as the benzoic acid. इसको benzoic acid बोलते हैं. और यहाँ पे हाइड्रोक्सी ग्रुप है, इसको क्या बोल के बुलाते हैं? हाइड्रोक्सी बेंजोइक एसिड बोल के बुलाते हैं. हाइड्रोक्सी बेंजोइक एसिड इज फॉर्म. इसको सैलिसिलिक एसिड बोल के भी बुला रहे. सो दिस इज द रिएक्शन इज कॉल्ड एज द Kolb's reaction. फिर एक बार रिपीट कर रहे हैं हम. Kolb's reaction. What is the Kolb's reaction? When phenol is treated with NaOH and followed by reaction with carbon dioxide in acidic media, that gives the hydroxybenzoic acid, also known as salicylic acid. This reaction is called as Kolb's reaction. Now next after this second important one that is a Raymer-Demon reaction. A Raymer-Demon reaction. What is this Raymer-Demon reaction? Once again I am taking this phenol only. So this is the phenol. When phenol is heated about 60 degrees with NaOH and chloroform, CHCl3 plus what? NaOH. NaOH और chloroform दोनों को मिला के about 57 to 60 degree C तक heat कर ले रहे हैं अपन. So as a result of that you will get the intermediate. So this is the intermediate is formed, that is once again OH की जगह ONA लिख लो, यहाँ पे CHCl2 आता है यहाँ पे. Now then this is the intermediate is formed. But the reaction हो रहा भाई ये NaOH के presence में ही हो रहा. So as a result of that what is formed? Just use check it out. ONA यहाँ पे as it is लिख ले रहा हूँ, यहाँ पे CHO लिख रहा हूँ. Now next ये हाइड्रोलाइसिस होके यानी कि फर्दर इसके अंदर कन्वर्शन होके यहाँ पे OH आ जाता और यहाँ पे CHO आता. तो aldehydic group CHO group is introduced on the right side ortho position of phenol, and this is called as the Raymer-Demon reaction. What is the Raymer-Demon reaction? When phenol is heated with chloroform and NaOH, that is the alkali, about 57 to 60 degrees C, You will get the intermediate hydrolysis of that gives the hydroxy at here. This is called as the benzaldehyde. This is the hydroxy that gives the hydroxy benzaldehyde. This is the reaction is called as the Riemer-Tiemann reaction. Once again I am repeating this definition. When phenol is heated with the chloroform and NaOH about this temperature and followed by hydrolysis of this, that gives the hydroxy benzaldehyde, salicylaldehyde बोल के भी बुलाते. This reaction is called as Riemer-Tiemann reaction. So this is about the another name reaction. Now next one is about the Williamson synthesis of ether. Williamson synthesis. Williamson synthesis. What is Williamson synthesis? I am taking alkyl halides, alkane minus hydrogen, that means C2H6 minus hydrogen, C2H5, alkyl halide, that is this one, C2H5Cl. When it is heated with the sodium eth oxide, sodium eth means what? C2H5, sodium ethoxide. This is the compound. When alkyl halide, that is ethyl chloride, is heated with sodium ethoxide, what happened in this reaction takes place? Simply a Na और Cl दोनों को reaction ये निकाल दो. As a result you will get the product. That means C2H5 O, यहाँ पे continuation में जो O है उसको लिख रहा हूँ, फिर यहाँ पे C2H5 लगा रहा हूँ. दो अल्काइल ग्रुप के बीच में ऑक्सीजन रहा तो इसका नाम क्या बोल के बुलाते हैं? बोले तो ईथर. कौन सा ईथर है भाई? डाइथाइल ईथर यहाँ पे फॉर्म हो रहा. वट एवर इट मे बी, व्हेन अल्काइल हालाइड्स आर reacts or treated or heated with the sodium ethoxide, the product is formed, that is the ether is formed. This reaction is called as the Williamson ether synthesis. This is about the third name reaction. Once again I am repeating. When alkyl halides are treated with sodium alkoxide, you will get the ethers. This reaction is called as Williamson synthesis of ether. Now in the organic chemistry, another name reaction that is important, that is what I am writing it here, that is the acetylation decarboxylation. Acetylation, first I am writing acetylation. What is acetylation or acylation? Acylation बोलते हैं आपको एसिटाइल ग्रुप याद आना, CH3COCl, एसिटाइल क्लोराइड बोलते हैं इसको, एसिटाइल क्लोराइड. चलो भाई फिर से वही अपन फिनॉल को ले लेंगे. फिनॉल कौन से भी यहाँ पे कंपाउंड को ले सकते हैं आप, अमाइंस को भी ले सकते हैं आप, बेंजीन को भी ले सकते हैं. उसको एसिटाइल क्लोराइड से रिएक्ट करने को बोलते हैं एसिटाइलेशन बोल के बुलाते हैं. When phenol is heated with or when phenol is treated with the acetyl chloride, देखिए simply H2Cl से निकाल दो और बेंजीन एज इट इज लिख दे के उसके ऊपर O लिख के साथ में COCH3 लिख दो. इसको बोलते हैं एसिटोफिनोन बोल के बुलाते. तो COCH3 को सब्स्टिट्यूट कर रहे हैं तो उसको बोलते हैं एसिटाइलेशन. When phenol is treated with the acetyl chloride in the presence of the Lewis acid, as a result of that you will get the acetophenone. This reaction is called as the acetylation reaction. I think you understood these reactions. Now then after this acetylation I am writing what is the decarboxylation. What is decarboxylation? Removal of carbon dioxide is called as decarboxylation. D means we are removing. We are removing what? Carbon dioxide. That is called as the decarboxylation reaction. So for the removal of this carbon dioxide we have to take this compound, that is this one, CH3COONA. Salt of the carboxylic acid is taken, and when salt of the carboxylic acid is heated with soda, that is called as the caustic soda, NaOH, and lime, CaO, called as quick lime, CaO and NaOH, दोनों को मिला के अपन क्या कर रहे हैं? गर्म कर रहे हैं, हीट कर रहे हैं. When salt of the carboxylic acid is heated with soda and lime, a decarboxylation takes place. कार्बन डाइऑक्साइड चले जाता है. देखिए अब ये पूरा चलेगा तो ये पूरा मिला के मैं क्या लिख रहा हूँ यहाँ पे, देखिए आप लोग क्या लिख रहा हूँ, 2 NH है, Na2 लिख दिया, और वो रहने से यहाँ पे क्या लिख दिया, CO3 लिख दिया। Na2CO3 इस फॉर्म CH3 हाइड्रोजन से कंबाइंड होके क्या फॉर्म होता है, यहाँ पे सिंपल अल्केन फॉर्म होता। सो ये अल्केन को प्रिपेयर करने का मेथड है। तो रिमूवल ऑफ CO2 को डिकार्बोक्सिलेशन बोलते हैं। रिमूवल ऑफ CO2 किससे हो रहा, साल्ट ऑफ दी कार्बोक्सिलिक एसिड से हो रहा, और कैसा हो रहा, CaO से मिला के गर्म करने से हो रहा। So when the salt of the carboxylic acid is heated with soda lime, alkanes are formed by means of the removal of carbon dioxide. This is the reaction is called as decarboxylation reaction. Now next one is the Cannizzaro reaction. Cannizzaro reaction. Cannizzaro reaction. What is Cannizzaro reaction? So in the Cannizzaro reaction I am taking the aldehydes, HCHO, it is the aldehyde. This is the aldehyde group. Aldehyde group के आगे कार्बन नहीं है, तो इसके ऊपर भी हाइड्रोजन नहीं रहते, कार्बन नहीं रहने से अल्फा हाइड्रोजन भी नहीं है। तो आई एम टेकिंग द aldehyde विदाउट अल्फा हाइड्रोजन, विदाउट अल्फा हाइड्रोजन वाले aldehydes को लेना, HCHO, 2 मॉलिक्यूल्स, दोनों को जोड़ने को बोलते हैं कंडेंसेशन। दो ऑल्डिहाइड मॉलिक्यूल्स को बेस के प्रेजेंस में हीट कर लिए आप, तो ये दो कंबाइन हो जाके प्रोडक्ट फॉर्म हो जाता, दैट इज कॉल्ड एज कैनिज़ारो रिएक्शन बोल के बुलाते। तो व्हाट इज द कैनिज़ारो रिएक्शन? Aldehydes without alpha hydrogen undergoes condensation in presence of the base and one molecule is converted to the first वाला क्या बन रहा है इधर देखिए, फर्स्ट वाला यहाँ पे क्या कर रहा हूं मैं, CH3, फर्स्ट वाले को CH3OH बना रहा हूं, एक अल्कोहल बन जाता, एक अल्कोहल बन जाता CH3, ये CH2 है ना, यहाँ पे CH2 और एक हाइड्रोजन दे दो, CH3 हो गया, और O के साथ में इसका हाइड्रोजन दे दो, तो CH3OH हो जाता, और नेक्स्ट वाला क्या बनता है, HCOONA, ऐसा सॉल्ट ऑफ द कार्बोक्सिलिक एसिड आता। So this is about the Cannizzaro reaction. Once again I am repeating, aldehydes without alpha hydrogen undergoes condensation. Without alpha hydrogen लिखना जरूरी है, अभी समझा हमें। विदाउट अल्फा हाइड्रोजन का मतलब ये कार्बन को आगे लगा हुआ, फंक्शनल ग्रुप को लगा हुआ कार्बन नहीं है आगे, तो इसीलिए इसको बोलते ऑल्डिहाइड विदाउट अल्फा कार्बन और विदाउट अल्फा हाइड्रोजन। So aldehydes without alpha hydrogen undergoes condensation in the presence of the base NaOH, and one is converted to the alcohol and second is converted to the salt of the carboxylic acid. This is the reaction is called as Cannizzaro reaction. इसको Cannizzaro reaction बोल के बुलाते हैं। प्रैक्टिस करना जरूरी है, you have to practice this reaction at least 4 to 5 times, then you will get this. नहीं तो फिर थोड़ा बहुत गलत लिख दिए तो भी मार्क्स चले आते हैं इसके अंदर। सही लिखना और एटम्स के और मॉलिक्यूल्स के अरेंजमेंट भी सही लिखना, बेंजीन रिंग पे किधर ऐड करना है वो भी देख लेके सही लिखना है आपको। नाउ देन फिर उसके बाद द नेक्स्ट वन इज aldol condensation. What is the aldol condensation? So during the reaction aldol is formed, therefore this is called as aldol condensation. Condensation का मतलब दोनों को जोड़ देने को बोलते हैं condensation। कौन से भी एटम्स या मॉलिक्यूल्स को निकाल दे के जोड़ दे रहा है यहाँ पे, तो वट एवर इट मे बी, मैं एक्सप्लेनेशन दे रहा हूँ, डेफिनेशन थोड़ा देखिए। वी आर टेकिंग दी ऑल्डिहाइड्स विथ अल्फा हाइड्रोजन, ऐसा सिंपल लिख सकते हैं आप। आई एम राइटिंग दिस ऑल्डिहाइड दैट इज एसीटॉल्डिहाइड, CH3CHO, इट इज एसीटॉल्डिहाइड। एसीटॉल्डिहाइड को फिर मैं क्या करा और एक एसीटॉल्डिहाइड से मिलाया, CH3CHO। देखिए यहाँ पे अल्फा हाइड्रोजन है, अल्फा हाइड्रोजन अगर रहा तो उसको बोलते हैं aldol condensation बोलते हैं, अल्फा हाइड्रोजन नहीं रहे तो क्या बोलते हैं, Cannizzaro रिएक्शन। तो दोनों भी ऑल्डिहाइड्स है, 2 ऑल्डिहाइड्स अंडरगोस कंडेंसेशन इन प्रेजेंस ऑफ द बेस। ओके, इन द प्रेजेंस ऑफ द बेस व्हाट आर द प्रोडक्ट फॉर्म, आई एम एक्सप्लेनिंग यू, जस्ट यू सी, आई एम राइटिंग द मैकेनिज्म। तो थोड़ा इसको ऐसा लिख ले रहा हूँ मैं, फर्स्ट मॉलिक्यूल को CH3CHO डबल बॉन्ड ओ बोल के ऐसा लिख रहा हूँ मैं, ये CH3CHO है, ये CH3CHO, दिस इज द फर्स्ट मॉलिक्यूल, एंड सेकेंड मॉलिक्यूल जो है इसको मैं ऐसा लिख ले रहा हूँ, HCH2CHO, दिस इज द सेकेंड मॉलिक्यूल। CH3 को ऐसा लिख लिया और साथ में CHO है, तो क्या करना है भाई, इसको एडिशन करना है। आप हाइड्रोजन को कार्बोनिल कार्बन पे इधर दे दो आप, और ये CH2 को लेके आके कार्बन पे ऐड करो। तो एज ए रिजल्ट ऑफ दैट यू विल गेट दिस इंटरमीडिएट CH3C आ गया, और ये हाइड्रोजन जो था वही लिख दिया। आई एम राइटिंग हाइड्रोजन लाइक दिस, and there are two bonds are there on that carbon. With one bond oxygen is there, to that oxygen I am adding this hydrogen like this. Now then another bond you have to write on the carbon like this. With this bond you have to add this CH2CHO. This is the intermediate, is called as aldol. इसको aldol बोलते हैं. It is a syrupy liquid and unstable one. It loses water molecule. ये जल्दी water molecule को दे देता. यहाँ से OH और यहाँ से हाइड्रोजन चले जाता. H वो H चले गया तो वाटर मॉलिक्यूल चले गया, तो दोनों के बीच में डबल बॉन्ड आता है। और करिए आप देखिए, यू सी दिस इज द प्रोडक्ट फॉर्म। CH3 लिख लिया, C के साथ में H लिख लिया, CH3CH, एंड डबल बॉन्ड, यहाँ से H निकाल दो, यहाँ से हाइड्रोजन निकाल दो, यहाँ से हाइड्रोजन, यहाँ से OH निकाल दिए, तो यहाँ पे एक हाइड्रोजन कार्बन पे बचा हुआ रहता, CH डबल बॉन्ड CH एंड CHO। दिस इज द ऑल्डिहाइड इज फॉर्म, अनसैचुरेटेड ऑल्डिहाइड फॉर्म हो रहा। ओके, क्रोटन ऑल्डिहाइड बोल के भी बुलाते हैं इसको। तो aldehydes with alpha hydrogen or aldehydes undergoes condensation in the presence of the base that gives the syrupy liquid called as aldol. It loses water molecule and forms the unsaturated aldehyde. This is the reaction is called as aldol condensation reaction. If two same aldehydes we are taking, अगर दो भी same type of aldehydes ले रहे हैं तो इसको बोलते हैं simple aldol condensation बोल के बुलाते हैं, simple aldol condensation. Two or same aldehydes we are taking, that is simple aldol condensation. अगर दो अलग अलग aldehydes हैं तो उसको बोलते हैं crossed aldol condensation बोल के बुलाते हैं। अलग अलग aldehydes कौन से है भाई, देखिए क्या कर रहा हूँ मैं, CH3 वो एक लिख लिया मैं। नो देन इसके साथ में क्या कर रहा हूँ, CH3 एक कार्बन बढ़ा के लिख ले रहा हूँ, CH3 CH2 CHO। दिस इज द अनदर वन। इसको क्या बोलते हैं, एसिटाल्डिहाइड बोलते हैं। इसको क्या बोलते हैं, प्रोपेनॉल्डिहाइड बोल के बुला रहे हैं। तो टू डिफरेंट मॉलिक्यूल्स ऑफ ऑल्डिहाइड्स अंडरगोस कंडेंसेशन इन प्रेजेंस ऑफ द बेस NaOH। यहाँ पे दो प्रोडक्ट्स आने वाले हैं भाई क्रॉस्ड ऑल्डॉल में। तो करना कुछ भी नहीं है, आप बाय हार्ट करके लिखना है। अब CH3 या CH, इसको क्या करो, इससे जॉइन कर दो आप CH3, उसके बाद में इधर बाजू का के ये क्या हो जाता भाई, ये CH, यहाँ पे CH2 CHO। दिस इज द प्रोडक्ट इज फॉर्म, ये प्रोडक्ट फॉर्म हो रहा। और एक प्रोडक्ट भी आने वाला है इसके अंदर क्रॉस्ड ऑल्डॉल में। तो कौन सा प्रोडक्ट है, CH3 या CH ले लो, यहाँ पे साथ में क्या करेंगे आप, फिर CH2 ले लो, फिर यहाँ पे क्या कर रहे हैं आप, डबल बॉन्ड डाल ले रहे हैं, यहाँ पे डबल बॉन्ड डाल लेके फिर यहाँ पे CHO लगा दे के यहाँ पे CH3 लिख ले रहे हैं। सो दिस इज अ प्रोडक्ट क्रॉस ऑल्डॉल कंडेंसेशन में दो प्रोडक्ट्स आ रहे हैं, इनको नोट करना है आप। दिस इज अबाउट द क्रॉस ऑल्डॉल कंडेंसेशन। If two same aldehydes are taking, that is called as the simple aldol condensation. If two different aldehydes are undergoes condensation, that is called as the crossed aldol condensation. This is about the another name reaction. इसी में से मैं बोले सो 5 या 6 reactions है, इसी में से ज्यादा है लेकिन मैं पूछ रहा है, और थोड़े नेम रिएक्शंस है, ट्राई टू कंप्लीट दैट आल्सो, वो VSAQ में आ सकते हैं। What is HVZ reaction? What is carbalamine reaction? एक है what is HVZ reaction? Hell-Vollard-Zelensky reaction है। Hell-Vollard-Zelensky reaction is nothing but the halogenation, that means chlorine is added in the presence of the red phosphorus। red phosphorus के presence में halogenation करने का नाम है Hell-Vollard, HVZ, Z means Zelensky reaction है। तो कौन सा कंपाउंड लेना है अपने को, This is the compound we are taking, that is the acetic acid, carboxylic acid ले रहा हूँ मैं, carboxylic acid CH3COOH, CH3COOH। ये देखिए ये है, इसको मैं क्या करा भाई, we are treating this CH3COOH with the chlorine in the presence of the sunlight, and red phosphorus is the catalyst we are using, reactive catalyst है ये red phosphorus। तो क्या होने वाला है, यहाँ पे अल्फा हैलोजिनेशन हो रहा। अल्फा का मतलब फंक्शनल ग्रुप को लगा हुआ फर्स्ट कार्बन क्या है, अल्फा कार्बन है, यहाँ पे अल्फा हेलोजिनेशन हो रहा है, यहाँ पे देखिए HCl चलेगा, एक क्लोरीन आके इधर सब्स्टिट्यूट हो गया, तो आहिस्ता आहिस्ता यहाँ हाइड्रोजन की जगह क्लोरीन लगा दो, ये हाइड्रोजन और ये हाइड्रोजन साथ में COOH। फिर नेक्स्ट स्टेप में फर्दर रिएक्शन होता है, यहाँ तक भी लिखे तो बस हो जाता आपको। ओके, नेक्स्ट स्टेप में और एक हाइड्रोजन ये क्लोरीन से सब्स्टिट्यूट हो जाता और फर्दर रिएक्शन हो रहा भाई, लास्ट में यहाँ पे तीनों क्लोरीन यहाँ पे सब्स्टिट्यूट हो जा रहे हैं, इसको बोलते हैं ट्राइक्लोरोएसिटिक एसिड फॉर्म होता है। फाइनल प्रोडक्ट इज ट्राइक्लोरोएसिटिक एसिड, यहाँ से यहाँ तक भी लिख के रख सकते हैं। दिस इज द अल्फा हेलोजिनेशन, दैट इज द रिएक्शन ऑफ द क्लोरीन of acetic acid in the presence of red phosphorus. This is the reaction is called as HVZ reaction or halogenation of carboxylic acid बोल के भी बुलाते हैं। फिर एक बार रिपीट करना है, तो देखिए आप जरा देखिए CH3COOH क्लोरीन मिलाया, ये हाइड्रोजन को निकालते जाना, क्लोरीन को सब्स्टिट्यूट करते जाना। वी आर सब्स्टिट्यूटिंग द क्लोरीन इन द प्रेजेंस ऑफ द हाइड्रोजन। This is the substitution reaction. Substitution of this chlorine on the alpha carbon is called as Hell-Vollard-Zelensky reaction. Next I am writing what is the carbalamine reaction. So this is the last reaction today I am explaining you. The last reaction is what is carbalamine reaction. Carbalamine reaction. Carbalamine means isocyanides are called as carbalamines. Isocyanide, cyanide बोले तो CN, isocyanide बोले तो isocyanide, ये फॉर्म हो रहा है, इसीलिए इसका नाम क्या है भाई, कार्बालामाइन रिएक्शन बोल के बुलाते हैं। सो कार्बालामाइन रिएक्शन में क्या कौन से कंपाउंड को लेना है आपको, NH2 प्राइमरी अमाइंस को लेना है। व्हेन प्राइमरी अमाइन इज ट्रीटेड विथ क्लोरोफॉर्म CHCl3, इट इज हीटेड विथ क्लोरोफॉर्म एंड KOH यूज करना है। स्टैइकियोमेट्रिक रेशियो है। एज ए रिजल्ट ऑफ दैट देखिए ये बेंजीन के ऊपर यहाँ पे NC सब्स्टिट्यूट होता है, इट इज द पंजेंट ऑफेंसिव ऑर्डर सब्सटेंस इज फॉर्म प्लस 3KCl plus H2O is liberated. So this is the reaction is called as which reaction, कार्बालामाइन रिएक्शन, वाटर को बैलेंस करना है, तो this is the reaction is called as carbalamine reaction. Once again I am repeating, when primary amines are treated with chloroform and KOH, at here a phenyl isocyanide is formed, it is the offensive order substance. So by means of this offensive order we can identify the primary amine and chloroform. Therefore this reaction is also called as isocyanide test. This is about the carbalamine reaction. During the course of reaction isocyanide is formed, therefore it is known as carbalamine reaction. Inshallah we will continue in next class.